That's odd because it wasn't set up to do that. You guys okay now? On Zoom?
Yes,
Yep.
that's great.
Okay, great. I have no idea what happened. Okay, so can we use this? So we want to find the maximum height. So we know the velocity is equal to 0 here. We're going to use this. Does it work? Maybe it does, maybe it doesn't. Let's find out. What's X naught? Where's the object start? 50. So this is 50. Looks great. What is V naught? 15. We don't know the T. The acceleration is this minus 9.8. We don't know the T again. What's the maximum height? Don't know. So we don't know the final X. We don't know the T. Is that going to help us? No. Okay. Now, how can I do this? But I would have to tinker with it. So let's say, you know, I don't know the T. I don't know the X. And so it looks like there's a problem. How can I patch it up? What are those three equations? This is one. The other one is? Let's hold off on that one. There's a reason why. Okay, what's the other one? Yeah, so I could say V equals V naught plus AT. Okay, what's the velocity at the maximum height? 0. The initial velocity? 15. The acceleration? Minus 9.8 times T. So I take this over here. So T is equal to 15 over 9.8. This is going to be something on the order of like 1.5. Okay? What would I do with that T? Yeah, now I could take this and put it in here. So what do I get? I get X equals, or X naught, 50. Our V naught is our 15. Our T value, there's this. So that goes in for T. Plus 1/2 minus 9.8 T squared. That T goes in here like this. And I get some number. Okay. The number is star. Okay, let's talk about star. It turns out only one person in this room is able to answer things with the word star and stuff like this, and it turns out to be me. So I'm going to claim the answer when you put it in your calculator, star. When you take your exams, do not give me answers like star. Okay, only one person can use star at a time, and it's me. Okay, so I'm going to call the X as star. This is a perfectly fine way to do it. Give me a way that's faster. And I actually asked somebody to hold off on a thought. So give me that thought again. Yeah, you have the V squared equation. So you have V squared equals V naught squared plus 2A delta X. So this is a faster way. What is V squared? This, 0. What is V naught squared? 15 squared plus 2. What is my friend A? Minus 9.8 delta X. Okay? So you solve it out for delta X, so I take this one to the other side, making it positive. And then divide through by the 2 times 9.8, and then that'd be my answer. Okay. So this would be what? This would be basically 225 over something like 20. And so this would be something on the order of like 12. I should say more like 11 something. What? So yeah, so this delta X would be where in the picture? The delta X is this guy. So if you wanted the maximum height, would be this 50 plus my delta x. So it'd be something like 50 plus 11, or something like 61 meters. Does that make sense? But there's a part B to this. Part B is find the time it takes for the rock to hit the ground. Proceed. How do we do that? How long is it going to take the rock to hit the ground? If you tell me what you said it equal to 0, and I agree, tell me what the it part is, and I'll agree with you. Exactly. Okay, so what you're going to do, you start with this. Okay. Where does the rock end up? On the ground. So if here's my axis like this, on the ground is 0. What is my x naught? Starting here, so it's 50. Plus v naught is 15. T plus 1/2 minus 9.8 t squared. Hey, what kind of equation is this? Quadratic. Okay, so what is A, what is B, what is C? Yeah, this is A, which is really minus 4.9. B is? And then here's my friend C. Does that make sense? Okay, now quadratic. T equals minus B plus or minus the square root of B squared minus 4 times A C all over 2A. Okay. Can somebody tell me what the square root is? This is 225. This one of the 2's going in there would make a 10. The other 2 here would make 100. What? The whole square root is what? Now, the square root is going to be positive. 34? All right, 34.7, I'm going to call it 35. Okay, divided by this guy here, 9.8. Now, the question is, we have 2 times. We have a plus sign, we have a minus sign. Which of the signs do we use? I'm hearing a plus sign. I'm hearing a minus sign. Okay, you can't have, okay, so let's use the plus sign. So you're going to say t equals minus 5 plus 35 over minus 9.8. Is this a good time? You get negative time here, right? So the top here would give you minus 20, would give you plus 20 over minus 9.8. This would give you something like minus 2. Okay? Your time can't be negative. So which time do you have to use? Which sign? You have to use a minus sign. So this is minus 50 over minus 9.8. So this is something on the order of 5. This right here, when you have something that is mathematically solves a problem, but makes no physical sense, does anyone know what that's called? More? The mathematicians call this an extraneous root. I mean, this does solve the mathematical equation. It just makes no physical sense. Okay? Questions to that? Part C. Now, I worded part C a very particular way. There's an assumption here that a lot of people do, but I don't want you to do it. There's a reason I worded it the way I did. Okay? So here's part C. Here's our building. We throw up that rock. It goes here like this. I want the velocity when it reaches the ground. Okay, if I can guarantee you when I ask something like this on the exam, what do you think a very common answers I get? 0. Okay, that's called the boring answer. Okay, you know, you want to do, you know, if I go like this, I want to know the velocity when it hits the ground, you can say 0. Okay, what is the question asking? It's right before it hits the ground. So even if the question asks, what is the velocity when it reaches the ground? There's something implied. It's always implied, you know, just before it hits the ground, right? If you jump off a building, right, is your velocity when you hit the ground 0? Eventually, when you're dead, okay? But in the process of dying, your velocity will not initially, okay? It's gonna hurt like hell, and there's a reason, because you have a velocity and you're smashing into the pavement. Okay, so there's something implied here. It's just before it hits the ground. Tell me how to do this. Give me 2 ways to do this. So we have time. Oh, give me 1 way, because we only have 3 minutes. Give me the fastest way. What? Okay, hold off on that one on Monday, okay? Give me the even faster way, because there's something subtle we have to do with that. Yes. Our V naught is 15 plus minus 9.8. What is our friend T? 5. Okay, so this is something on the order of like minus 50. Like this. So this velocity is something like minus 35. What does the minus sign mean? It means downward. Okay. Hold off on that other way. I want to finish the problem so we can start something new on Monday. Okay. For part D, find the average velocity. So what is the average velocity for the object? What is the definition of average velocity? Day 1. Change in position, delta x, over change in time. Okay, what is a change in position? Remember, it's this. What is a change in position? Okay, did it go from here to there? This is the initial position, and here's the final position. This part here, right? This part and this part here, that's not going to matter with anything. It starts here, it ends here. What is the change in distance there? One of those is true. Okay, is it positive 50 or negative 50? Why is it negative? How do you always do a change? Final minus initial. So you take this value, which is x equals 0, minus the initial position, which is x equals 50. So this is really 0 minus 50. And how long did we say it takes to go up and then down? We said 5 seconds about. Okay, so the average velocity is something on the order of minus 10 meters a second. Okay. Have a great day. What?